Hello, we have some questions from logarithms. So by now you guys are probably deep into the logarithms as far as the equations and the rules and learning the properties are concerned. But in 6.4 is when we start learning the actual graphs and what the graphs look like. And had a couple of questions from a couple of different individuals, and it was 75 and a problem like 78, I believe. It may be 82 or something like that. So I'm thinking actually this is actually not 78 but 82. So, yeah, number 82. And, well, you have to graph these two functions on 75. Y equals the natural log of 3x. A little different than the book. I think it's like the book's got like natural log of 2x. I'm not going to do exactly the same problem. And on 82, this was a little different than what the book has as well. And but anyway, I'm going to graph these natural log graphs. But as a reminder, what a natural log graph looks like. All as if all logarithms, they all go through the order pair 1, 0, and they will go through the base, comma 1. Well, on a natural log, the base is e. So e is 2.7, so it'll go approximately 2.7 up 1. So it'll go through these 2 points. And so there is a vertical asymptote on the x-axis. So just looking at the natural log function, the range is all real numbers, continues down, continues up, and the x's, the domain, is starts at 0 and it goes to infinity. It doesn't include 0, so it's 0 to infinity. So this is a natural log graph. This is what it looks like. Well, on these two problems here, we are going to do some shifting and stretching and turning things upside down and vertical reflections on some of these. And so that's what this is all about. So like you did on chapter 3.5, we're doing the same thing here. Now, on y equals the natural log of 3x, this is one of those horizontal stretches, horizontal compressions that we didn't really talk about too much about when we hit those. So again, 75 is one of those multiples of 3, but it gave you one of those types of problems. So don't worry so much about number 75, but I have a question on it, so I'm going to answer it. But when you have the natural log of 3x, it has to do with along the x-axis. So on a horizontal stretch or horizontal compression, this is actually a horizontal compression. So the number in front of the x is 3. So we'll compress it by a factor of 3 back towards the x-axis. So it's going to make it squished in. So every point has to be 1/3 of the distance it is from the y-axis. So right here, instead of at 1, 0, it'd be at 1/3, 0. Instead of 2.7 up 1, you take 1/3 of 2.7, and then it's 0.9, 1. So it's very, very compressed. So it looks like that. So this point right here, take to 1/3 the distance, to 1/3. This is 2.7. You take 1/3 of 2.7, it's 0.9, which is about right there. As a matter of fact, it probably doesn't even have that much of a hook to it. And realistically, it probably has this to it. That's probably a little bit more realistic. And but again, this is the horizontal compressions and horizontal stretches of X. So this is a horizontal compression. If it was a 1/3 X out here, then it would take the graph and it would just stretch it out by a factor of 3. And but again, we did not talk about these types of transformations, so you would not be tested over a problem like number 75. But this is just kind of like an FYI thing. This is what they look like. Now on number 82, now we have done these. Okay, this one here is the negative natural log of x plus 2 plus 3. So what this is going to do to the graph, first of all, I would rewrite it as this way, because the plus 3 that's in the beginning will be your vertical shifts up and down. Actually, this is going to be up 3. And so I always do that last, so that's why I put it on the right, left to right. So the first thing I do is I shift the graph 2 units to the left. So this graph has to go 2 units to the left. So the vertical asymptote, which is in the y-axis, will now be at -2. This point right here will go 2 units to the left. So it would have to go here. The 2.7 comma 1 is not going to be 0.7 comma 1. So it's going to be about right there. So 1, 2.7, and then 1 right there. So right now, that's what the graph would look like if you move it 2 units to the left. Now there's a negative in front, so we know that's a vertical reflection. We've had enough of those, we know what that does. So this one right here will go down here, and so now it looks like this. So it takes this part and just flips it over, and now it looks like that. And now finally, the plus 3 will move the whole graph up 3 units. So this point goes up to here. This point right here will go up 1, 2, 3 to there. And so the graph will have this shape. Okay, so it looks like that. So it takes the normal function, moves it to 2 units to the left, turns it upside down, and brings it up 3. Just like all the transformations like did when these things were applied to it. Okay. Now there's other things that we had to do on these 2 problems. We had to find the domain and the range and find any asymptotes that you might have. Well, on number 75, the domain, just look at the graph. It starts at 0, so it didn't move left to right, so it stays 0 to infinity. The range, negative infinity, and it goes up to positive infinity. So, oops, there we go. And then the asymptotes, well, it's on the x. So the vertical asymptote. There we go. The vertical asymptote is at the y-axis, so it's going to be x equals 0. Okay, so it didn't move left, didn't move right. And so these problems, you have to do this as well. 82, kind of the same thing. The domain don't start at 0, it starts at -2. So it's -2 and to the right. Now remember, domain is x's and range is y's. And then range continues up and it continues down. So it's negative infinity to infinity. And the vertical asymptote is x equals -2, because that's where it's at. So these other questions that they're asking, the domain, the range, and vertical asymptotes, are really easier to do if you get the graph first. Of course, if you miss the graph, you're going to miss some of these probably. So they kind of go together. So these are easy as long as your graph is correct. If it's incorrect, then you're probably going to miss it. Now, the range you probably shouldn't miss. The range will always be all real numbers on these things. And the vertical asymptote might be different situations depending on whether you move it or you don't move it, like you didn't move it on this one. And same thing with the domain. So, but anyway, this is 75 and 82 in section 6.4, and that's it.